With its vast landscapes, deserts, rivers, mountains, and oceans, Earth may seem huge to us. But it's actually just a tiny dot among the giants of space. But the solar system, filled with the moon, the sun, rocky planets, gas, and ice giants, is much more incredible than we realize. In the first video of a series of 2 videos exploring the enormity of our universe, we compare the actual size of the Earth, the moon, the sun, and all the planets, and look at the scales that upset our perception of size. In the second video, we will go beyond the solar system and explore the gigantic dimensions of our universe as we travel between stars and galaxies. If you're ready, we'll start with the first destination of this journey, our planet Earth. The starting point of our journey is our planet Earth. The Earth is a rocky planet, consisting of 7 main continents with 70% of its surface covered with water. Mount Everest, the highest point above sea level, is 29,031 feet or 8,849 meters high, and the deepest point is the Mariana Trench, 35,791 feet or 10,909 meters below sea level. The first observations that our planet is round go back to the ancient Greek period. Pythagoras and later Aristotle realized that the Earth was round by looking at the Earth's shadow on the moon during a lunar eclipse. The first scientist to calculate how big our planet is and how close it is to the value we know today is Eratosthenes, who lived in the 2nd century. Eratosthenes made a calculation based on the angular difference of the sun's rays coming at different angles to the Alexandria and Aswan pits in Egypt on 21st June, and calculated the length of the Earth's circumference in a very close value despite the technological possibilities at that time. Later, the length of the Earth's circumference was recalculated with high accuracy by the Persian scientist El-Biruni, who lived in the Middle Ages, using trigonometry. With the precise measurements we make today, we can calculate the length of the Earth's circumference as 24,901 miles or 40,075 kilometers all the way around the equator. This is the same distance as traveling between New York and Los Angeles 10 times by plane. Also, the approximate diameter of our Earth is 7,926 miles or 12,750 kilometers from the equator. In the face of this size of our Earth, the Earth's crust is actually relatively thin, contrary to popular belief. While the thickness of the Earth's crust varies between 15 to 45 miles or 25 to 70 kilometers on average, even the deepest point of the oceans is only 6.8 miles or 11 kilometers deep. Our Earth is also surrounded by an air mass called the atmosphere. The boundary between Earth's atmosphere and outer space isn't sharply defined. However, most scientists consider the Kármán line, situated 62 miles or 100 kilometers above the Earth, as the point where this transition occurs. This is because almost all of Earth's atmospheric mass is located below this altitude. After mentioning the size of these layers that make up our Earth, we can now slowly move away from our Earth and continue our journey into the depths of space. Let's visit the first artificial satellite that greets us immediately after leaving the Earth's atmosphere. This satellite is also known as the International Space Station and is approximately 250 miles or 400 kilometers above the ground. This space station, which we also call the ISS for short, is about the size of a soccer field. The space station, which has a speed of 16,590 miles per hour while orbiting the Earth, completes 1 revolution in 90 minutes. In other words, it makes about 16 revolutions around the Earth in 1 day. The size of our satellite moon. 4.5 billion years ago, our satellite moon was formed as a result of the collision of a planet the size of Mars with the Earth, as a result of the pieces of the Earth moving away from the Earth and coming together in an orbit. The moon has a diameter of 2,159 miles or 3,474 kilometers, which is about 1/4 of the diameter of our Earth. The average distance of the moon from the Earth is 238,855 miles or 384,400 kilometers. This means that light traveling at a speed of about 300,000 kilometers per second reaches the moon from the Earth in 1.28 seconds. In other words, when we look from Earth, we see the moon as it was 1.28 seconds ago. Another interesting fact about the moon is that the gravity on the moon is about 6 times weaker than on Earth. Someone who weighs 120 pounds on Earth weighs about 20 pounds on the Moon. Finally, if we talk about the Moon's orbit around the Earth, it completes this orbit in about 27.3 days. But the time to complete the phases of the Moon corresponds to about 29.5 days. We can observe the phases of the Moon as a result of the Sun's rays hitting the Moon's surface at different angles and coming to Earth during the Moon's orbit around the Earth. We continue our space journey from where we left off by slowly moving away from the Moon. Now, we will examine how big the Sun and our solar system are and how far the distances in our solar system are. Size of the solar system. The Sun is a gigantic ball of gas located approximately at the center of the solar system, which performs nuclear fusion reactions and radiates heat and light energy throughout the system. This gas ball consists of 71% hydrogen and 27% helium gases. If we give you the mass of the Sun as a value, it will not make much sense, but its mass is approximately 333,000 times the mass of our Earth. Our Sun is so gigantic that it constitutes 99.86% of the mass of the entire solar system. But in terms of size, the Sun is actually a very small part of the entire solar system. If we compare the distance of the entire solar system to the planet Neptune, with a city 6 miles or 10 kilometers in diameter, the Sun would be about the size of a 5-foot or 1.5 meters diameter balloon in the center of this city. The solar system in the images or videos you see does not reflect the reality. The reason why such images are used is preferred for us to see the whole picture together more easily. If we need to give a value, the diameter of our Sun is approximately 870,000 miles, or 1.4 million kilometers. In terms of ratio, the diameter of the Sun is about 109 times the diameter of the Earth, and in terms of volume, it is 1.3 million times the Earth. This means that if it were possible, we could fit 1.3 million Earths inside the Sun. If we compare the size of the Sun and the Earth, if the Sun were a balloon 1.5 meters in size, our Earth would be the size of a marble 1.5 centimeters in size. The distance between the Earth and the Sun is approximately 93.2 million miles, or 150 million kilometers. Astronomers also call this distance 1 astronomical unit. The reason for using this unit is that it is easier to determine the proportional distances of the Earth and other planets than the metric system. In addition, when the distance between the Earth and the Sun was not known exactly, the astronomical unit helped astronomers to understand how far the Sun and other planets were proportionally. Geniuses such as Kepler, Copernicus, and Newton always used the astronomical unit when calculating distances and other physical quantities in the solar system. I will explain in more detail how to calculate the distance of the Sun, planets, and stars to us in another video. The history of calculating the size and distance of the Sun goes back to ancient Greece. Thanks to the radar technology currently used, we can calculate these distances precisely. If we take the distance of the Earth to the Sun as 1 astronomical unit, the distances of the other planets to the Sun are as shown in the figure. The nearest planet, Mercury, is about 0.39 astronomical units away, while the farthest planet, Neptune, is about 30 astronomical units away from the Sun. As an analogy, if we put the Sun, which is 5 feet or 1.5 meters in diameter, in the center of a stadium, the Earth would be about 548 feet, or 167 meters, from the center of this stadium, about the size of a marble 1.5 centimeters in diameter. Of course, the solar system does not only consist of planets. Beyond Neptune, the solar system also includes the Kuiper Belt, with its countless asteroids and comets, and the Oort cloud, which marks its outer boundaries. The diameter of the solar system, with the Oort cloud, is estimated to be about 100,000 astronomical units. This means that the effect of the Sun's gravitational pull extends to unimaginable distances from the Sun. At this point, distances can hardly be measured even in astronomical units. So much so that astronomers prefer a larger unit of measurement, the light year, instead of the astronomical unit. 100,000 astronomical units, the outer limit of the solar system, corresponds to approximately 1.58 light years. In our next video, We will explain in detail what a light year is and how it is calculated. And that's just our neighborhood in space. From the moon to the mighty sun and the giant planets, we've only scratched the surface of the cosmic scale. But beyond the solar system lies a far greater vastness, filled with stars, nebulae, galaxies, and structures that challenge our imagination. In the next video, we'll journey beyond our sun, travel between the stars, and try to grasp the true scale of the universe. Don't forget to like the video, subscribe the channel, and turn on the notification bell so you don't miss the second part of this mind-blowing cosmic journey. See you in the next video.